Now we are already logged into the server and we can do anything here as we would do on a normal server. But what if this server was not actually physically present here? For example, what if the server was in a data center somewhere in the US? Now, obviously, we will not be able to physically access the server. That's why we have remote logins. This is why we use Secure Shell or SSH to access the server. Basically, this gives an encrypted channel or encrypted connection to the remote server where we can execute commands as if we were physically present in the server. Now that we are logged into this server, what we see here is made possible using a software called Shell. Shell is a software that lets us do stuff on our operating system. Basically, this is an interface to the operating system. This is where you run commands. Right now we are in a shell called bash. If you just type in bash and press enter, well, it just opens another instance of the shell bash. Another shell which is more basic is sh or shell. If you type in sh and press enter, will be put into this different prompt that doesn't have the username and the host name. It's just the dollar symbol. Now this is called the POSIX shell or SSH. Let's go back to bash. While on the topic of remote login, I said we will be using SSH to log into our server. But before SSH, there were other tools or other protocols used to access servers. So I'm gonna give an exercise. Exercise is to research about Telnet and RSH, which are kind of like older tools that were used to manage a server remotely. So as I said before, SSH allows us to connect to our remote server. Let's say this is our remote server and let's say this is in the US. And here we are. This is our SSH client and this is the internet. Now SSH allows us to connect to our remote server securely. By securely, I mean nobody will be able to see what we are typing or what kind of commands we are running, or anything that we are sending from our client to the server. Nobody will be able to see because it is encrypted. But how is it encrypted? SSH uses symmetric encryption. Symmetric encryption means both parties uses the same key to encrypt and decrypt the whole session or the whole traffic. So I have another exercise for you. Research about symmetric versus asymmetric encryption. Okay, so SSH uses symmetric encryption to encrypt the traffic. That means both the server and the client needs to know the shared key. So there is a shared key. So this shared key is used to encrypt the traffic from the client side and the server side. So that means both should know the same key. Now, how is that possible? Like, we cannot just send it over the internet to the server, right? Because then that kind of defeats the whole purpose. Whoever is listening on the network will be able to see the key before the encryption even starts. This is where the magic of key exchange algorithms comes into picture. And one such algorithm is called Diffie-Hellman's Key Exchange algorithm. This is a very interesting, really genius algorithm that is used to exchange keys securely. Now I'm gonna give another exercise. I want you to go and research how this works. This is really cool algorithm and I'm just gonna show how exactly it works in theory. In theory as in like how is that even possible to share a secret across a public medium without actually having to share that secret? Now if we go into Wikipedia, yeah, here they have this really cool image. They explain the concept using paint. So here, let's see, we have Alice and Bob. Alice wants to share a common secret to Bob without actually having to share it through the public medium here. So Alice and Bob have a common paint and that is yellow, and they have their own secret paints too. Alice have this red and Bob have this, what is this color? I don't know what color this is, but Bob has this color. Now if Alice mixes her common paint and the secret paint, then she gets this color. Similarly, when Bob mixes his common paint and the secret color, he gets this color. So now they actually share this color across the public medium. Anybody who is listening to this, or anybody who is able to see that Alice is sharing this color of paint with Bob, or Bob is sharing this color of paint with Alice, they still will not be able to make out what was their secret color, because separating the mixture is very expensive and it's not practical. So now if Alice adds the same secret color again back to the mixture shared by Bob, and similarly if Bob mixes the secret color with the shared mixture from Alice, they will both arrive at the common secret. So this is how basically the principle of Diffie-Hellman Key Exchange algorithm is, right? So now let's talk about SSH. Now how do we use SSH? You use an SSH client to reach the server. And there are a lot of SSH clients available out there, and one of them is Putty, or whatever. You can use this, or since here I'm using Windows, I have already installed Windows Subsystem for Linux, or WSL. You should actually install this too. It's pretty simple. Just go to Google and search for install WSL. There are like a lot of Microsoft documents explaining how to install this. It's pretty simple. I have already installed it. So basically what this does is it actually gives you a full Linux experience, or full Linux virtual machine inside your Windows operating system. So as I said before, you can either use Putty or any SSH client. In this case, I'm just gonna use the Windows Subsystem for Linux, which already have an SSH client. Here, as you can see, the SSH client is already installed. Now remember, this is my Windows machine, and this is my Windows machine's WSL, Windows Subsystem for Linux. This is different from the virtual machine that we have here. Alright, so how do we access the server via SSH? It's pretty simple. We use SSH username at IP address. That's it. So now we need to find the IP address of our new server here. Use the command IPA. So now here is an interesting thing. Here you can see there are two interfaces here, or network interfaces. I guess I'll talk about the network interfaces in a future video, but for now, as you can see, there are two IP addresses. One is 127.0.0.1 and the other one is 10.0.2.15. Basically what this means is our virtual machine does not have any access to the host network. So now, to be able to access this server from our local machine, we need to enable something called Bridge Network Interface. I'm going to show you how to do that. I'm just going to shut down the machine, send the shutdown signal. Now back into the VirtualBox Manager, click on Settings, under Network. So here, as you can see, it says it's attached to NAT, or Network Address Translation. Now I'm going to talk about Network Address Translation in a future video, not this one. So for now, we're going to change this and change it to Bridged Adapter. So here, I have an Ethernet connection connected to my laptop. So I'm going to use this Realtek USB family controller, which is the Ethernet cable. But if you are connected to the Wi-Fi, you should choose the network adapter that corresponds to your Wi-Fi and press OK. So now let's start the VM again. Again, the username. So I'm logged in again. So the command IPA is used to show all the network interfaces. Here, as you can see, now it has an IP address in the Wi-Fi net, in the same network as my host machine, 192.168.0.120. Now if I open my Windows command prompt and type in ipconfig, here the IP addresses, IPv4 address is 192.168.0.116, which is on the same network as this. So that means now I should be able to access this machine from my Windows machine. Now let me try that. Okay, this is the first time we are connecting to this server, and this is the fingerprint of the server. Because this is the first time that we are connecting, we have not much option. We just say yes, and what it does is I'll show you what it does. But for now, I'm gonna enter the password. Okay, let me go back to this. So what it means is we need to make sure that when we are entering this, SSH Mansoor at this IP, there needs to be a way to make sure that we are connecting to the correct server. This is where this fingerprint comes into picture. So basically, this is just a way to make sure that we are connecting to the correct server. So if at some point in future the IP address is used by another server, let's say that server is not in our control, and then if I try to access the server using the same username and password, and that password is actually being sent to that server, so an attacker can actually mimic that and receive that password. So to avoid that, we use this key fingerprint, or the ECDSA key fingerprint. Now the next time when you connect to the server using the same IP address, if for some reason that server has changed, or if that IP address is used by another server, that will produce a different fingerprint than this one, and then our SSH client is going to tell us that the key has changed, you should be careful. We logged into the server using a username and password. This is not the best way to do it. We should avoid it as much as possible. There is a better way to log into remote servers using public keys or SSH keys. Key-based authentication uses public and private key pair to authenticate. Let's create our first SSH key. So we use the command SSH keygen and press enter. Now it's going to create a public private RSA key pair. So by default, it's going to create under the location .ssh/id_RSA. So if you already have a key here, be careful because this is going to override that. So I'm just gonna press enter. So now it's asking for a passphrase. What it means is the private key that it's going to generate will be encrypted using a passphrase. That means even if someone is able to get hold of that private key, they will not be able to use it unless they know the passphrase. I'm just gonna go ahead and leave it empty. I don't want any passphrase for now. So yeah, it's created the public and private key. Let's take a look at the public and private key. So here, as you can see, the location, it says .ssh id_RSA is the public key, and identification means the private key, that is id_RSA. So we use the cat command to see the content of a file. So if I do that, this is a private key. We just generated this private key. So if you actually have access to this private key, that basically means you have access to any server that this key have access to. Now obviously I just generated this key, so it doesn't have any access anywhere. But if it did, then you can just use this key to log into any server that I already have access to. So this is why we say the private key is very sensitive. You should not leave it without a passphrase, or you should be very careful when dealing with the private key. So now if we look at the idrsa.pub, this is the private part, this is the public part of the key. So the private key always stays in your local machine, or wherever the SSH client is, the private key always stays there. The private key is always private in the SSH client or our local machine, and the public key is actually sent to the remote server. Now how do we use the public key based authentication? So we use a command called SSH copy ID, then the username and the same IP address as the SSH command that we used previously. Now it's going to ask to enter the password as before. I'm just going to enter the password. So now it says number of keys added 1. Now try logging into the machine with SSH Mansoor at the IP address and check to make sure that only the keys you wanted were added. Let's just check. So this time we were able to log in without any password. Now let's take a look at what happened on the server side. So we are already logged into the server as the user Mansoor. If we use the command pwd, pwd is the command used to print the present working directory. And if I use the ls-l command, it lists all the directories and files in the current directory. There is nothing there. We use the ls-la command to display everything, including the hidden files and directories. So now we can see one hidden directory and a bunch of hidden files. So if we take a look at the contents of the .ssh directory, here you can see a file called authorized keys. And let's take a look at the contents. So now this is the public key that we used on our local machine. This is the public key. This is our public key. Okay, so our public key gets written into this .ssh authorized keys files. This is what Linux uses to authenticate you. So if you already have access to this server, you can simply edit this file and add your own public key, and you will be able to access the server without having to enter the password. That's how you use key-based authentication with SSH.